Hi everyone, this is Elad from Astrolabe Diagnostics, and I'm going to discuss how to interpret the results from Astrolabe's Differential Expression Analysis module. As a quick reminder, we're looking at a paper from Glassberg et al. At Mount Sinai, and in this study, they wanted to examine how the expression of different markers in immune cells vary as they applied an extracorporeal perfusion system. In other words, they wanted to model cell traffic through blood vessels, and we are going to examine the results through the lens of differential expression analysis. As we have seen in the experiment setup video, we have uploaded the FCS files into Astrolabe's cloud-based system, and we've set the experiment design, the different patient groups, patient IDs, um, treatments, and time points. Furthermore, we added these auxiliary columns, each of which allow us to compare the patient group and the control group across the two conditions, pre and post, in each one of the time points. This is the 10-minute, this is the 30-minute, and this is the 60-minute. To access the results themselves, I'm going to go to the Analysis tab. We've set up 3 different analyses, and we can choose either one of these 3. I'm going to start by going to the 10-minute time point. And the first view we see is this heat map, where every row is one of the cell subsets, every column is one of the markers, and the level, the value, is the fold change across the different conditions. The brighter the color, the greater the fold change. And I'm actually going to take a step back and focus on the compartment level. So we're going to look at each cell subset compartment as a whole instead of specific cells such as memory and naive cells. And you'll notice here that 2 of the markers seem to vary across all of the compartments. So I'm going to pick them, CD61 and P38. And 2 of them, pCRAB and PRQ12, seem to be myeloid specific. So I'm going to click on them as well. Then I can scroll down and look at each marker separately. So we now have separate sections for each one of the markers. Let's start by looking at CD61. First of all, we have a heat map that shows us the transformed value of this marker in each one of the samples. Every row is a sample, every column is one of the cell subsets, in this case compartments. I will sort this by the time point, and you will notice that CD61 is low in almost all of the controls, and it is high in almost all of the patients. For aggregate statistics, I can click on the feature box plots. And now I'm going to have 4 different panels, one for every cell subset. In each panel, we have a box plot for each one of the conditions, controls pre and post, patient pre and post, and every dot is one of the samples. During setup, we've chosen the 95th quantile, and these are the values you see here. And the trend we see for CD61 is uniform across the different compartments. It seems to be low in the controls, and it seems to be high in the patients, and there doesn't seem to be much of an increase between them. We do see a bit of a difference with this big outlier, and to dig deeper into that, I'm going to click on sample dot plots, and now every figure is showing us single samples. So just to clarify, these are the same dots we've seen here. Over here we see them as box plots, and over here we see them as single dots. And you will notice that control number 1 has a much higher CD61 in the myeloids and NK cells when comparing the post time point to the pre time point. And this is the outlier we've seen before. However, setting that outlier aside, the same trend persists. CD61 seems to be lower in the controls, higher in the patients, and not much of a trend between the pre and post time points. Let's close CD61 and look at P38. I'm going to switch back to the feature box plot. And we're seeing a bit of an opposite trend. It looks like P38 is higher in the controls, it is lower in the patients. However, here we actually do see a trend when it comes to the myeloids. It looks like P38 goes up between the pre and post time points, and the magnitude of the increase is stronger with the patients. In other words, this seems to be a bit of a, let's say, a 30% increase. And by the way, all this is quantified in the reports export. This is a much more significant increase. It's closer to a 2-fold increase. Finally, let's look at the 2 markers that seem to be myeloid specific. And in pCREB's case, it looks like there is an increase in pCREB between the pre and post time point. However, this increase is identical no matter if you're looking at the controls or the patients. And looking at PERQ-1-2, once again we're seeing an increase in PERQ-1-2 between the controls and between the pre and the post, and this seems to be the same whether we're controlling patients. By the way, looking at the NK cells, just notice that it looks like PERQ-1-2 seems to increase in the NK cells between the pre and the post in the controls, but not in the patients. Two last thing I would like to mention. First of all, we can repeat the same process for the other time points. So if we look at time point 60, and again switch to the compartment level, look at the different compartments, and let's say CD61 and P38, we can see if the trends persist. In this case, we will notice that CD61 behaves about the same for B cells, NK cells, and T cells. However, it seems to increase after 60 minutes for the myeloids between the pre and the post. And in this case, the increase for the controls is more significant than the one for the patient. P38 seems to repeat about the same trend. And of course, we can do the same thing with the other markers. For example, if you would like to look at PERQ-1-2 in the myeloid compartment, we can see how the trends change. Another thing we can do, and I'm going to go back to the 10 minutes, is to look at specific cell subsets or even go into the profiling level if you so choose. So your resolution can go as deeply as you want. And one of the things we've seen before in the compartment level, we looked at myeloids and PERQ-1-2, and we saw this increase between post and pre. Let's see whether this trend persists for all three different types of monocytes. So I've picked the three different types of monocytes, and we're going to look at the feature box plots. And in this case, it looks like this trend persists for the intermediate and the classical monocytes. However, we're seeing a different trend for the non-classical monocytes. I hope this video gives you some ideas on how to utilize differential expression analysis in your experience, in your experiment. As with other components of Astrolabe, it's really about leveraging the power of the interface to navigate between different subsets, between different markers, and try to get these hypotheses that make biological sense within the context of your experiment. If you have any questions, please reach out. I'm Elad at astrolabediagnostics.com, and you can also reach out to support@astrolabediagnostics.com. And as always, please subscribe to us on LinkedIn and on YouTube for more of these videos and the latest news on immune monitoring and Astrolabe. Thank you for your time and have a good day.